Welcome to my channel. Today we are going to discuss about the fourth unit multiple choice question and answer. So already one video I posted from the fourth unit, the sampling process. Okay. So now we are going to discuss about the next two topics in that fourth unit. One is Z transform and another one is DTFT. So already we discussed the so many that is I posted so many videos about the Z transform and DTFT problems. Okay, so the Z transform of standard signals, DTFT discrete time Fourier transform of standard signals, and the properties of Z transform, properties of DTFT, inverse Z transform, inverse DTFT, all problems we solved in that fourth unit. So if you want to study that topic means you go and learn from the signals and system playlist in my channel. Okay. So I will give link for those videos in the description box also. You can verify it. Okay. So now we are going to see the things about the Z transform in this video. So the first question you see, the Z transform of the sequence x of n is equal to del of ns. What does it mean by del of n? It's a unit sample sequence or unit impulse sequence. So what is the Z transform of the unit impulse sequence? So the four answer is given 1, 0, 1 by Z is Z. Okay. So if we want to solve this problem means, so already you know the Z transform formula. What is the Z transform formula? The Z transform of any sequence x of n is nothing but the capital X of Z is equal to summation n equal to minus infinity to infinity x of n z power minus n. So in this formula, we have to substitute the value of x of n. What is the x of n here? Del of n. So you know del of n nature. What does mean by del of n? The del of n is having the amplitude 1 only at a time n equal to 0. So for the remaining time, the sequence is not at all having any amplitude. This is the del of n sequence. Okay. So we have to substitute this del of n value in the Z transform formula. So that's why this summation n equal to minus infinity to infinity. So our x of n is available only at n equal to 0. So that's why put n equal to 0 in the above formula. So we will get that x of 0 is only 1. Okay, for the remaining n value, the signal is not at all having anything. Okay, so that's why 1 into Z power 0. Okay, put n equal to 0 in these two things. So we will get 1 into Z power 0. So 1. So this is the Z transform of del of n. Okay. So already you know, if you are taking any transform for the unit impulse sequence, we will get the answer is 1. So you should remember the standard answers. The Z transform of del of n is 1. Okay. And the next one, the Z transform of x of n equal to u of n. What is u of n? It's a unit step sequence. Okay. So if we want to find the Z transform of unit step sequence, so similar to the previous problem, we have to substitute the x of n value in the Z transform formula. Okay. So already we solved these problems in a separate videos. So this is the solution for that problem. So we have to substitute the x of n value here. So u of n, the unit step sequence is having the amplitude 1 for the n value from 0 to infinity. So that's why the summation is changed from n equal to 0 to infinity 1 into z power minus n. Okay. So then this z power minus n, it can be written as z power minus 1 to the power n. Okay. So already we are having the standard geometric series summation n equal to 0 to infinity a power n means the answer is 1 by 1 minus a. So according to this relation, so the summation, the answer for the summation is that 1 by 1 minus z inverse. So the u of n, the unit step sequence, the z transform answer is 1 by 1 minus z inverse. Okay. So if you want to convert this z inverse into positive z means, so this z inverse, it can be written as 1 by z. If you are taking LCM and if you are rearranging, we will get the answer z by z minus 1. Okay, so you just remember these answers. So the unit step sequence is having the Z transform answer is 1 by 1 minus Z inverse or Z by Z minus 1. So here you see, here all answer is given in positive Z. So Z by Z minus 1. So the first is the answer. Z by Z minus 1 is the Z transform of U of n. Okay. So the standard answer you have to remember. For del of n, the answer is 1. for u of n z divided by z minus 1. Okay, then the next one, find the z transform of u of minus n. Okay, so what is u of minus n? It's a time reversed version of u of n signal. Okay, the above problem u of n. U of n means the signal is available for n equal to 0 to infinity. So u of minus n means this signal is it's a time reversed version. This signal is available for n equal to minus infinity to 0. For 0 to infinity, the signal is not at all available. This is the u of minus n. So in order to solve this problem, so we have to use the time reversal property of Z transform. Okay. So according to this property, if the sequence x of n is having the Z transform, capital X of Z means, if we want to find the Z transform of x of minus n, that is the time reversed signal, the Z transform is that x of Z inverse. That is, in the x of Z answer, you just replace Z by Z inverse. That is Z inverse by Z inverse. Okay, so that is the thing. So we know that, so our aim is to find out the Z transform of u of minus n. So what is the base signal of u of minus n? U of n. So we know that the u of n is having the Z transform answer is 1 by 1 minus Z inverse or Z by Z minus 1. Okay. So according to this time reversal property, so the Z transform of u of minus n is nothing but in the x of Z answer, we have to replace Z by Z inverse. So that's why we will get Z inverse by Z inverse minus 1. Okay. Then this Z inverse, it can be written as 1 by Z. Similarly, this Z inverse can be written as 1 by Z. So if you are taking LCM, so we will get the answer is that 1 by 1 minus Z. So 1 by 1 minus Z is the transform of u of minus n. Okay, so 1 by 1 minus Z. So this is the transform of u of minus n. Okay, then the next one, the Z transform of minus u of minus n minus 1. Okay, so u of minus n minus 1 is nothing but the signal is available for the time n equal to minus infinity to minus 1. Okay, that is a u of minus n minus 1. The signal is having the Z transform is that 1 divided by 1 minus Z inverse. This is the answer. Okay, so similar to this method, we have to solve. Okay, so like u of n. Similar to u of n, we have to solve u of minus n minus 1. So if you are solving, we will get the same answer. Okay, similar to u of n, the u of minus n minus 1 is also having the same answer 1 by 1 minus Z inverse, that is Z by Z minus 1. Okay, so the answer for this minus u of minus n minus 1 is 1 by 1 minus Z inverse or Z by Z minus 1. Okay, but the ROC for the u of n and u of minus n minus 1 is different. Okay, ROC is different, but the answer, the Z transform answer for these two problem, it remains same. Okay, that is the one. Then the next question, find the Z transform of del of n plus 3. So already we calculated the Z transform of del of n. So what is the Z transform of del of n? It is 1. Okay, so then according to, we have to find the Z transform of del of n plus 3. So in order to calculate the Z transform of del of n plus 3, we have to use the property, time shifting property. Okay, time shifting property of Z transform. What is time shifting property? According to the time shifting property, if the x of n sequence is having the Z transform as capital X of Z means x of n plus k. So n plus k means the Z transform is that the x of Z multiplied with Z power k. Similarly, if you want to find the Z transform of x of n minus k means Z power minus k multiplied with x of Z. Okay, so this is the time shifting property. So using this property, we are going to solve this del of n plus 3 or del of n minus 1, n minus 2, that problem. Okay, so you see that. So we know that the Z transform of del of n is 1. Okay, so according to this time shifting property, so Z transform of del of n plus 3 is, so here how much shift? 3 shift. So Z power, the k value is 3. So, and x of z value is 1. So, 1 into z power 3. So, the answer is z power 3. So, here z power 3 is the answer. Similarly, if it is a del of n minus 3 means, okay, if you want to find the z transform of del of n minus 3 means, so here the answer is that z power minus k. So, z power minus 3 into 1. If it is a del of n minus 3, delayed signal, this is an advanced signal, okay. So in a similar way, we have to solve. Okay, then the next question, find the Z transform of a power n u of n for a greater than 0. Okay, so a power n u of n, you know, a power n u of n, it is nothing but that is a exponential signal. Okay, exponential signal. So if you want to find the Z transform of a power n u of n means, so using the usual procedure, that is we have to write the Z transform formula. Then we have to substitute the value of x of n. So here what is x of n? A power n u of n. So already you know any signal multiplied with u of n means the limit is we have to restrict to 0 to infinity. So n equal to 0 to infinity a power n z power minus n. So if you are that is from the two thing we have to take n power as a common means we have to write a into z inverse to the power n. Okay. So according to that generic summation series, so the answer for this series is that 1 by 1 minus this a into z inverse. So if you are converting this z inverse into 1 by z means we will get z by z minus a. Okay. So a power n u of n signal is having the z transform is that z by z minus a. Okay. So you just remember these answers. So z by z minus a is the answer. Simply u of n means z by z minus 1. A power n u of n means z by z minus a, the constant a. Okay. So this is the z transform. Then the next one, x of n equal to a power n u of n and x of n equal to minus a power n u of minus n minus 1 have the same x of z and ROC. So the statement is correct or not. Okay. So if you are solving these two problems separately, we will get the Z transform answer is same. Okay. So just now we solved a power n u of n problem. So what is the Z transform of a power n u of n problem? 1 by 1 minus a z inverse. Okay. So in the previous only we solved. So the if you are rearranging, we will get z by z minus a. Okay. Similarly, minus a power n u of minus n minus 1. For this sequence also, if you are taking z transform, we will get the same answer, z by z minus a. Okay. So the x of z value for these two signal remains same. Okay. But the ROC is different. So you see the first signal a power n u of n. What is a power n u of n? It's a causal sequence. That is causal means the signal is available for the positive time axis. The second signal minus a power n u of minus n minus 1 is a anti-causal sequence. This sequence is available for the negative time duration. Okay. So, you know, for according to the property of ROC, okay, so ROC of Z transform, if the signal is a causal sequence means the ROC is the modulus of Z greater than that A value. Okay. If it is an anti-causal sequence, the ROC is modulus of Z less than that A. Okay, this is the conditions. So here, you see our question, if the two signal have the same x of Z and ROC, okay, but ROC is different. So the statement is false. Okay, so this two signal is having the same x of Z value, okay, same Z transform value, but the ROC is different. Okay, one is modulus of Z greater than A. That is the exterior part of the circle having radius A. The second signal is having the ROC is interior part of the circle having radius A. Okay. So in ROC, these two signals can differ. Okay. Then the next one, find the Z transform of x of n equal to a power modulus n problem. Okay. So this problem is a very important big question. Okay. So we solved separately this question a power modulus n. So if you are taking Z transform for a power modulus n, so already you know the a power modulus n, it can be split as, that is modulus n means n can take for positive value as well as negative value. if it takes positive value, the signal it behaves differently, a power n u of n. If the n value is negative, means the signal it behaves differently, a power minus n u of minus n minus 1. Okay, so the a power modulus n, it can be written as addition of these two signals. So if you are taking Z transform for these two signal, we will get the answer is the Z transform of the first a power n u of n is z by z minus a, and a power minus n u of minus n minus 1 is z by z minus 1 by a. Okay, so this is the answer for our total problem, a power modulus n. So you see which one is correct? Z by z minus a plus z by z minus 1 by a. Okay, so this is the answer. In the next choice, some here minus is given. Okay, so it is wrong. Here z by z minus 1, z by z minus. This is wrong. This is the correct answer. Okay, z by z minus a plus z by z minus 1 by a. Okay, then the next standard signal, find the Z transform of cos omega n u of n. Okay, cosine sequence. The cos omega n u of n is having the Z transform, answer is that this one, Z into Z minus cos omega divided by Z squared minus 2Z cos omega plus 1. Okay, this is the answer for cos omega n u of n. Okay, so you have to remember it. Similarly, find the Z transform of sine omega n u of n. Okay, so the answer is the first thing, Z sine omega divided by Z squared minus 2Z cos omega plus 1. Okay, so for cos omega n and sine omega n, the denominator it should be same. Okay, so numerator is different. So for cos omega n, the numerator is Z into Z minus cos omega. Okay, here Z sine omega, but the denominator it is same for these two problems. So these standard answers you have to remember it. Okay, so del of n. So that is I will give one table for the standard signal, the Z transform of the standard signal. So you just see, that is the first signal. The first standard signal is del of n. Okay, the signal is del of n. The del of n is having the Z transform value is 1. Okay, and ROC is, so using this table, that is the full video is based on this table only. Okay, the del of n is having the Z transform 1, and ROC is entire Z plane. Okay, then U of n, the standard, next standard signal U of n. The U of n is having the Z transform answer 1 by 1 minus Z inverse. If you are rearranging, we will get Z by Z minus 1. Okay, so we will get Z by Z minus 1. So the ROC for the unit step signal is modulus of Z greater than 1. Okay, modulus of Z greater than 1. That is, if we want to calculate the ROC, this denominator we have to equate to 0, and we have to find out the value of Z. Okay, so Z minus 1 greater than 0. So what is the value of Z? Z greater than 1. Okay, that is the ROC. Similarly, that is a power n. Okay, so that a power n, here they are taking e power minus an. So the a power n means the signal is having Z transform 1 by 1 minus az. That is Z by Z minus a. Okay, then the next one. So here there's a given. So you see a power n u of n. The signal is having the Z transform 1 by 1 minus a Z inverse, or it can be written as Z by Z minus a. Okay, so the ROC is modulus of Z greater than a. Similarly, minus a power n u of minus n minus 1 is also having the same Z transform value, but ROC is different. Okay, so you see this is greater than a, this is less than a. That is a different. Okay, then n into u of n. N into u of n means this is that is a ramp sequence. Okay, unit ramp sequence. The ramp sequence is having the Z transform Z inverse by 1 minus Z inverse. Okay, or it can be written as Z by Z minus 1 the whole squared. Okay, so you just remember any one of the thing. Z by Z minus 1 the whole squared. And the ROC is modulus of Z greater than 1. Okay, then this U of n and U of minus n minus 1 is having the same ROC. but sorry, same Z transform, but ROC is different. Modulus of Z greater than 1, here modulus of Z less than 1. Okay. Then the next one, sine omega n. So you see cos omega naught n u of n, sine omega naught n u of n, this is the answer. Okay, so if you want to convert into positive Z means we will get Z into Z minus cos omega naught divided by Z squared minus 2Z cos omega naught plus 1. Similarly, this is a sine omega naught problem. Okay, similarly, a power n cos omega naught n, a power n sine omega naught n. So what is the difference means in the cos omega naught n u of n problem, we have to replace Z by Z minus A. Okay, so all these problems we solved separate video in the signals and system playlist. Okay, so all these problems we solved. Okay, so you just remember the standard answers for that problems. Okay, then the next one, based on the ROC, some questions. So first, if a sequence is causal, then the ROC is dash. Okay, so the ROC properties in Z transform. So there are some properties of ROC is that if the given sequence is a causal means the ROC is modulus of Z greater than A. Okay, that is the ROC region of convergence is exterior part of the circle having radius A. This is the condition. If the sequence is anti-causal, then the ROC is interior part of the circle. So that's why the modulus of Z less than A. This is the condition. Okay, causal means, for example, U of n problem, A power n U of n. These are all the causal sequence. So for that causal sequence, ROC will be modulus of Z greater than A. Okay, so you see this table also. So you see this cos omega naught n U of n, sin omega naught n U of n. Okay, this one. So U of n, if you are multiplying U of n means this is a causal sequence. So the sequence you see ROC value is all ROC values are greater than some value. Okay. Similarly, you see U of n problem, n into U of n, modulus of Z greater than 1. Simply U of n, modulus of Z greater than 1. Okay. So for causal sequence, the ROC is exterior part of the circle. That is modulus of Z greater than some modulus of A value. Similarly, for anti-causal sequence. So what is anti-causal means? U of minus n minus 1. Okay, that is the negative sided signal is called as, okay, negative time sided signal is called as anti-causal signal. So for anti-causal signal, the ROC you see less than modulus of Z less than some value. Okay, so this is the property of this ROC. So for if the sequence is causal, the ROC is modulus of Z greater than A. Okay, where A is some number. Similarly, for anti-causal signal, the modulus of Z less than A. Okay. Then the next one, for causal sequence, the ROC is exterior of circle of radius R. Yes, it's a true only. Okay. So this question, this 11th question is differently asking. So here the ROC is modulus of Z greater than A. So what is modulus of Z greater than A means? We have to draw a circle of radius A and the portion outside this circle is called as modulus of Z greater than A. Okay. So that's why for a causal sequence, the ROC is exterior part of the circle having radius R. It's a true. Okay. For right-handed sequence, the ROC is entire Z plane. Okay. For right-handed sequence means causal sequence, the ROC is entire Z plane. Okay. No, it's a false. For right-handed sequence, the ROC is not an entire Z plane. Okay, that is for this exterior part of some circle. Okay, except this one, this is the ROC. So it's a false. Then if the ROC of x of n is R1, then the ROC of a power n x of n is R1 into A, R1 divided by A divided by R1 plus A. So R1 divided by A. Okay. The ROC of x of n is R1 means the ROC of A power n x of n means x of n is the region divided by the A. Okay. Then the next one, what is the ROC of unit impulse signal del of n? Okay. So already you know the Z transform of del of n is 1. Okay. So what is the ROC? ROC, it's a entire Z plane. Okay, so in the table also the ROC is given. Del of n is having the Z transform answer 1. Okay, so irrespective of any value of Z, the del of n is having the Z transform value constantly 1. So that's why the ROC is entire Z plane. Okay, so entire Z plane. This D is answer. Then what is the ROC of sequence x of n equal to a power n u of n? Okay, so already know what is the Z transform of a power n u of n? Z by Z minus a. Okay, so in order to calculate this ROC, this denominator part we have to take it as this denominator part we have to take it as greater than 0. So Z minus a greater than 0. So Z it should be greater than a. Okay, so modulus of Z greater than a is the ROC. The denominator part we have to equate it to 0 and we have to find out the value of Z. Then what is the ROC of U of n, unit step sequence? So what is the Z transform of U of n? Z by Z minus 1. Okay, so according to this, the denominator Z minus 1, it should be greater than 0. Okay, so Z is greater than 1. So ROC. Okay, so all this ROC is also given here. So you see del of n, entire Z plane, U of n, modulus of Z greater than 1. Okay, so a power n u of n, a power n u of n, modulus of Z greater than a. Okay, so all answers given. So similarly, what is the ROC of minus a power n u of minus n minus 1? So you see this already you know a power n u of n and minus a power n u of minus n minus 1. This two signal is having same Z transform, but ROC is different. So for this is a causal sequence. So ROC is greater than a. So this is an anti-causal sequence. So already you know the ROC is modulus of Z less than a. Okay, less than a. Then what is the ROC of x of n equal to a power modulus n? Okay, so the Z transform of a power modulus n already we calculated. Okay, so this in this the Z transform of a power modulus n, you see Z by Z minus a plus Z by Z minus 1 by a. So according to this first answer, the ROC is modulus of Z greater than a. Okay, then according to this second one, this is the anti-causal sequence. So modulus of Z, it should be less than 1 by a. Since the second answer is it's an anti-causal sequence. Okay, so for anti-causal sequence, you know, the ROC is interior part of the circle. So if you are combining these two things, we will get the answer. So if you are combining these two things, we will get modulus of Z, it should be greater than a, but it should be less than 1 by a. Okay, that is the combined ROC condition. So you see modulus of Z greater than a, less than 1 by a. So first is the answer. Modulus of Z less than 1 by a, but greater than a. So this is the combined condition, combined ROC for a power modulus n problem. Okay, and what is the ROC of cos omega n u of n? Okay, so cos omega n u of n, sin omega n u of n. So these two signal is having the ROC modulus of Z greater than 1. Okay, since it is a causal sequence, so greater than some value. So cos omega n, sin omega n, the ROC is modulus of Z greater than 1. Okay. Similarly, for sin omega n u of n also, the ROC value is modulus of Z greater than 1. Then what is the ROC of a power n cos omega n u of n? Okay, so for a power n cos omega n u of n, the ROC is modulus of Z greater than a. Similarly, for a power n sin omega n u of n also, the modulus of Z greater than a. Okay, so in the table, that is this problem we solved as a separate video. I will give a link for those videos in the description box. Okay, this is the answer. So you see the ROC modulus of Z greater than a. Modulus of Z greater than modulus a. Okay, so these are all the answers. And then the next one, the range of value of a for which the system will be stable if the impulse response of discrete time system is a power n u of n. Okay, so if for one system, the h of n impulse response, you know, h of n. The h of n is a power n u of n means So for what is the range of values of A at which the system it should be stable means, so the condition is that the A it should be between -1 to 1. Okay, so the value of A it should be in between -1 to +1. At that condition only that discrete times that discrete system it should be stable. Okay, for the remaining value of A the system is unstable. The next question, the ROC does not contain any pole. Yes. Okay. So this is also one of the property of ROC. In ROC region, no pole will be available. Okay. So above the pole only we will get the ROC. So it's a true. The ROC does not contain any pole. It's a true only. Then the ROC of finite duration sequence includes entire Z plane except Z equal to 0 and Z equal to infinite. Okay, so that is if you are calculating one finite duration sequence, for example, x of n equal to 1, 2, 3. If you are calculating Z transform, and for that, if you are calculating the ROC means that ROC of the finite duration sequence includes entire Z plane except Z equal to 0 and Z equal to infinity. It's a true only. Okay. Then what is the Z transform of del of n plus k? Okay. So already one problem, del of n plus 3 we solved. So in the place of 3, there is a constant k is there. Okay. So using the time shifting property, we are going to solve. So in order to solve this problem, so already you know the Z transform of del of n is 1. Okay. Then according to the time shifting property, the Z transform of del of n plus k is that x of z multiplied with z power k. So Z transform of del of n plus k is, what is the x of z value? 1. So 1 into z power k. So z power k is the answer. Okay. This is the Z transform. Then the next one, find the Z transform of x of n equal to del of n plus del of n minus 1. Okay. So here using linearity property, we are going to solve. That is, we have to find a Z transform for individual signal and we have to add. Okay. So first one, Z transform of del of n we have to calculate. What is the Z transform of del of n? 1, you know. Then what is the Z transform of del of n minus 1? According to this time shifting property, we have to solve. So according to time shifting property, Z transform of del of n minus 1 is 1 into Z power minus 1. Okay. So Z power minus 1. So therefore the Z transform of the total signal is that the first answer 1. Okay. For the signal 1, for this del of n minus 1, the answer is Z power minus 1. So 1 plus Z inverse is the answer. So B is the answer. Okay. Then the next question, what is the Z transform of x of n minus n naught? Okay. This is that is the property they are asking. Okay. Generally they are asking. So here some del of n minus 1, del of n plus k. What is the Z transform? They are asking here. What is the Z transform of x of n minus n naught? Okay. So the Z transform of x of n minus n naught is, so you see the according to time shifting property, x of z multiplied with z power minus n naught. Okay. Here amount of shift is n naught. In the previous thing k is given. Instead of k here n naught is given. So answer you see x of z multiplied with z power minus n naught. Similarly x of n plus n naught means x of z into z power plus n naught. Okay, this is the one. Then the next one, what is the Z transform of x of n equal to R of n and its ROC? So what is R of n? Ramp signal. Okay, the ramp signal means n into u of n. Okay, so for this ramp signal, what is the ROC means? Z by Z minus 1 the whole square. Okay, so similarly, we have to substitute the R of n value in our Z transform formula and we have to find out. If you are calculating, we will get the answer is that Z inverse by 1 minus Z inverse the whole square. Or if you are rearranging, we will get Z by Z minus 1 the whole square. This is the answer. And ROC is modulus of Z greater than 1. So Z by Z minus 1 the whole square with ROC is modulus of Z greater than 1. Okay, this is the is a transform of unit ramp signal. R of n means unit ramp signal. Okay, so these are all the some of the problems in the Z transform. Okay, so in this we discussed that is what is the Z transform of del of n. Del of n is 1. Okay, so you see this table, the Z transform of del of n sequence is 1 and ROC is entire Z plane. Then del of n minus n naught. Del of n minus n naught means this is the shifted signal. So the shifted signal is having the Z transform as x of Z into Z power minus n naught. Okay. Then U of n signal, Z transform as 1 by 1 minus Z inverse or Z by Z minus 1. Okay. So you can see any, this is Z inverse form or is this a plus form. ROC is modulus of Z greater than 1. Okay, then U of minus n minus 1 is also having the same Z transform value, but ROC is less than 1. Okay, this n into U of n, this is nothing but a R of n, ramp signal. Okay, R of n is Z by Z minus 1 the whole squared. Okay, then these are all these different signals. Then A power n U of n is having the Z transform Z by Z minus A with the modulus of Z greater than A. Okay, then this A power n and minus A power n U of minus n minus 1 is having the same Z transform value, but ROC is one is greater than A, one is less than A. Okay, then sine cos omega naught n U of n, sine omega naught n U of n, A power cos omega naught n U of n, A power sine omega naught n U of n. These are all the some of the standard signals. Okay, so for these signals, the answer they are asking as well as the ROC for the particular signal. Okay, so you just remember these ROCs. Okay, so thanks for watching my channel and please subscribe my channel for more videos. In the next video, so we will discuss about the DTFT and in some more problems about this Z transform. Okay, so thank you.